We wish to estimate, number 3 now, we wish to estimate what percent of adult residents in a certain county are parents. Like what percentage of, our county is parents, has kids. Out of 500 adult residents sampled, 95 had kids. Based on this, construct a 95% confidence interval for the proportion of adult residents who are parents in this county. So if you wanted to figure out what percentage, and by the way, who uses this all the time is marketing people. This is, there's all kinds of careers now using statistics in marketing. They want to know what people, what the different percentages are of people in an area because they want to know how to market to them. So they do this stuff all the time. So if you wanted to figure out what percentage of our county has kids, our parents, if you wanted to market some new baby equipment or whatever, I don't know, then you'd want to figure out what percentage of our county has kids. Well, how are you going to do that? How are you going to figure out what percentage of the county has kids? You don't have time to go around and ask everybody in the whole county if they have kids. Can't even make that happen. What are you going to do? You pick a sample, you take 500 at random, and based on your sample, you try to draw a conclusion. So that's what we're doing here. We're saying out of 500 in a sample, 95 had kids. Is that making sense? So you just take a little sample. You can't ask the whole county. There's too many people. So you just take a sample, and out of your 500, 95 have kids. You use that to estimate what might be the true percentage who have kids, who are parents, in the whole county. So how are we going to do it? We go to our calculator again. Same thing. So we hit stat and go over to tests. Hit enter. Go down, down, down to the 1 prop z interval and hit enter. And then it'll ask you X and N and C level. So what is X? That's going to be 95 for my example. 95 had kids out of 500. N is always the total, right? Confidence level, what do we want? 95 on mine anyway. So you put that in as a decimal and hit enter and get your numbers. So I'm going to do it too. $95, 500, confidence level 95. Let me show you on my calculator. So I'll turn it on. All right. All right, here we go. So I hit stat, go over to test, go way down to one prop Z interval, which is A right there. Hit enter. X, what was X? 95 on my example anyway, 95 out of 500. Go down, the confidence level is 0.95 for mine. Enter, enter, there we go. There is the confidence interval. And the 0.19, that's the exact percentage of the sample. Has a little hat, I call that P hat. That little triangle above the P, we call that hat. Seems like I'm making that up, but that's really what it's called. That's the official name. P hat, that's its hat. P hat is 0.19. What is that? Notice that's right in the middle of this interval. 19% means that's 19% of your sample. 19% of your sample had kids. So that means we are confident that the real, for the whole county, is the real percentage is somewhere between 15 and 22. All right, so let's, that's more like, that would round to 16 and 22. So that, see, they took 19, they went down 3, up 3, basically 3.5 really. All right, so let's go back to the iPad so you can see that. All right, so the confidence level came out to be, what did it come out to be? Came out to be 0.15561, comma, 0.22439. Now we need to round those. What do they want to round? Did they say? 3 places. Oh, this one's 3 places. Okay. So I got to round to 3 places. So 3, 3. So that's going to be 0.156, isn't it? And 0.224. 0.156, 0.224. Okay, now notice down here, it wants us to give something else. Again, it says 3 places. What are we supposed to do? What do they want us to do? They want you to put right here the 0.19. This is like the air. See how it's plus or minus? That's like give or take. Does that make sense? Where did I come up with that 0.19? That was the number on the calculator. Remember? Let me show you that again. You go back. See right there? See that p hat equals 0.19? That's on the calculator. What is that? That means that's the middle. That's the middle of the interval. That's what your sample came out to be. Let's go back. Right, so let me write that down here for us. P hat is 0.19. That goes right here. How did our calculator come up with that? All the calculator did was take 95 and divide by 500. If you do that, it's 0.19. That's what the calculator did. Because in our sample, 95 out of 500 people had kids, right? So that's 19% of the people we surveyed. So that's what that number is. That's the very middle of the interval. That's the percentage for our sample. So when we sampled 500 people, 19% of them, 0.19, had kids. So they're wanting us to give the answer in 2 forms. Right here, we gave the confidence interval. We're saying it's the real answer is between 0.156 and 0.224, and others between 16% and 22%. We're 95% sure that for the whole county, that the real percentage of people that have kids is between 16 and 22. And then they want us to give it as an error margin statement. So we're saying we are saying that we believe the true percentage of people in the county that have kids, their parents, is 19%, because that's what our sample came out, 19%. Give or take a certain error margin. Well, how do you know what the error margin is? Do you have an idea? How am I going to come up with the error margin? Nobody knows? It's going to be the 0.19 minus the left number, meaning that number. You might say, well, can't we just use a 156? Well, that's a rounded number. It's not smart to use a rounded number. Never use a rounded number to figure out a new answer. Go back to the original. So it's going to be 0.19 minus 0.1556. 0.19 minus 0.15561. And I'm getting error equals 0.03439. And they want me to round to 3 places. Put the line right there, 0.034. 0.034. Is that making any sense? Let me say a little bit more about that, because I want that to really make sense for you. And
Mr. Heron,
Today I have on a
can that be a negative number?
it could be. It could be a negative number. It's possible.
Okay.
That's right.
So, Mr. Heron, are you using the whole number or are you using just the 0.156? When you subtract it from the 1.
Yeah, gotcha. Right here.
Yes.
Just the whole 15561. 0.19 minus 0.15561.
Yes.
There we go. Yeah, so I want you to see why that is. I don't want that to be some magic trick Mr. Heron does, because it won't stick with you very well that way. Remember what it is we're doing here. We the reason this works and is true is because 19% is the middle. Remember? 19% is the middle. We're saying 19% of the middle, go back some amount, go forward some amount, and we know the left edge is 0.15561, and the right edge is 0.22439 for our interval, right? That's the left and the right. And 19 is the middle. That's what our calculator told us. 19% is middle. So basically, the error margin is how much it goes forwards and backwards from the 19%. Does everybody see that? So you could find that two different ways. You could take the big one, subtract the middle, or the middle, subtract the small one. Either way, it'll work. I just said grab the middle, subtract the small one. See, the error is the amount of jump from the middle, the 0.19, up to the top number and down to the little number. That's what it is, right? That's what an error margin is. It's the give or take, the up or down from the middle. Does that make sense? So if somebody gives you the whole margin, let me back that up. We use it over here. The margin, use the numbers back here before you round it. Never use a rounded number to figure out something new at any time in math. Never use a rounded number because it's not the real number, right? Rounded numbers are great for a final answer, but they're not great to use in a further calculation. So always go back to the number that was not rounded. And so we say, okay, so if 0.19 is the middle, right? That's what our calculator told us. That's our p hat. Calculator is saying 19% of our sample has kids. Then we're saying, okay, what percentage of the whole county? Well, we take that sample number, that 19% in the middle, and we give or take error because our sample might not be perfect. We might have got a weird group that has more kids or less kids or whatever. We might have got a weird group. There could be error in there, random error. How much? Well, how much error? Well, we have the bottom and the top that our calculator told us for the confidence interval. So the error is the jump from the middle up or down to the top or bottom number. So you can just subtract the top number minus the middle or the middle minus the bottom, which is what I did. I took the middle minus the left number, the bottom number, and that gave us the error amount. So what we're saying is we think 19%. What does this mean? This means that 19%, we believe 19% of the whole county has kids, because that's what happened in our sample, 95 out of 500, that's 19%. So we believe 19% of the whole county has kids, but we know there could be error in that because our sample's not perfect. We're saying there's an error margin of 3%, 0.034, 3.4%. We're saying, yeah, it might be higher or lower by about 3.5%. It's not perfect. So that's what you'll see in polling studies. They'll give a percentage they think that the candidate's going to get, and then they'll have an error margin because they know their study's not perfect. And so there we go.